guys, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 947. Most stones removed with same row or column. Okay, so let's read the problem statement first. On a 2D plane, we place n stones at some integer coordinate points. Each coordinate point may have at most one stone. A stone can be removed if it shares either the same row or the same column as another stone that has not been removed. Okay. Given an array stones of length n represents the location of the ith stone, return the largest possible number of stones that can be removed. Okay, so see, this is my example number 1. Okay, so here in total we have 6 stones, right? 1 2 3 4 5 6 stones are there. Okay, and these are the coordinates. Okay, so this stone A, okay, let's name it A. Let's name this stone as B, which is available at index 1. Okay, so this is nothing but indexing, and here I'm just giving the names, okay, for your reference. Okay, so A stone should be placed at this coordinate. Okay, this is x coordinate, this is y coordinate. Okay, so let me place this A stone here. Okay, so this is nothing but my x-axis, right? And this is nothing but my y-axis. So A stone is at this 0 by 0 coordinate. Okay, so I have placed A here. Then B stone is at 0 1. Okay, so 0 1, so at this position. Okay, x is 0, y is 1. Okay, so C stone is at this position 1 by 0, right? D stone is at this position 1 by 2. Okay, so 1 2. Okay, this coordinate. E stone is at 2 1. Okay, so E stone I am placing it here. Then this F stone is at this 2 by 2, right? So now we need to see how many stones we can remove. From C I can move to this A because both are in same column, right? Both are in this column, right? 0 number column, right? From A I can move to B because both are in same row, right? This is single same row, right? Same row, right? Then from B I can move to E because both are in same column. Okay, same column. Here see y coordinate is same for both of them, right? From E I can move to F because both are in same row, right? From F I can move to D because both are in same column, right? So this is one single component, right? From C I can move to D, right? So here let's suppose using this C and A, both are in same column, so I have removed this C. From A and B, okay, both are in same row, so let's say I have removed this A. Both B and E are in same column, so let's say I have removed this B. Both E and F are in same row, let's say I have removed this E. Both F and D are in same column, so let's say I have removed this F. Okay, in the end I'm left with D. So in maximum, how many stones I'm removing here? 5, right? So can I do one thing? Can I write it like this? Total numbers of stones I have and the number of total components. So from C to D I can reach in one go, right? So number of components is just 1, right? So 6 minus 1 is equal to 5. This is going to my output, right? So I hope that this is clear. So now if you want to solve this using your explanation given in example number 1, so see here, remove stone 2 by 2 because it shares the same row as 2 1. Okay, so let's remove this 2 by 2 because it shares the same row as 2 1, right? Remove stone 2 1 because it shares the same column as 0 1. Remove this stone because it shares the same column as 0 1. Okay, remove stone 1 2 because it shares the same row as 1 0. Okay, remove this stone 1 2 because it shares the same row as 1 0. Remove stone 1 0 because it shares the same column as 0 0. Okay, so remove stone 1 0 because it shares the same column as 0 by 0. Okay, remove stone 0 1 because it shares the same row as 0 0. Okay, so we have removed this. So in total, how many stones we are removing? 5 only, right? So simple now. 6 minus number of components that I have. Component simply means that from one stone to other stone can I reach in one go. That is just one component. Okay, 6 minus 1 is equal to 5. Okay, so now let's understand this with this example. Okay, so let's say you have 3 stones like this. Okay, so this is just one component and there are 3 stones here like this. Okay, so in total how many stones you have here? 6. Okay, and how many components you have? This is component 2, this component, total 2 components here. So 6 minus 2, 4 stones you can remove maximum. So is it true? So let's say, so using both are in the same column, so I can remove this. Both are in same row, I can remove this. Okay, so here one, from here one stone I can't remove. Both are in same column, I can remove this. Both are in same row, I can remove this. Now here I am also left with 1, right? So see here, I have removed 1, 2, 3, 4, and this is my output. So 6 minus 2, 2 is not even number of components. This is what I need to do, and I will get my answer. How many stones I can remove maximum. Okay, so now let's write the code for this one. So first let's calculate the total number of stones that I have. So let me just increment the side here. So here write int n is equal to stones dot length. Okay, then after that let's create one list. Okay, and list of integer array, list of integers, right? And let's name it as adjacency list, new list. Okay, now after that what you need to do here, create one adjacency list to store graph connections, right? So for that what I'm going to do, I'm going to run one loop for int I is equal to 0, I is less than n, I plus plus, and here inside this adjacency list, okay, at this particular index I is equal to new array list. That's it. Okay, so now after that I have to build the graph. We have to connect the stones that share the same row or column. Okay, so how I'm going to do that? So I'm going to use 2 loops. Okay, so first I'm going to fix this and I'm going to check all other stones. Okay, so whether this stone has same row or column with any other stone. Okay, this is what I need to check. So what I'm going to do, int I is equal to 0, I is less than n, I plus plus, and here for int j is equal to I plus 1, j is less than n, j plus plus. Okay, and inside this I'm just going to check if stones at this at my row, okay, is equal to stones at this j of 0. Okay, or this is what I need to check now. I need to compare this with this one, then I need to compare this with this one, then I need to compare this one with this one. Okay, same way I need to compare this one with this one, this one with this one, this one with this one. Okay, so on. Okay, so this is what I have to check here. So stones of I and here at 1 index, okay, is equal to stones j and here 1. Okay, so if this is satisfied, okay, then in that case I have to add the values in the my adjacency list array, right? So add this index, okay, what my list, add this one. In this list I'm just going to add the value of j. Okay, then same way adjacency list, okay, add this j dot add I. Okay, this is what I need to do. So what is actually happening here? So let's see. So see here, I have to create the adjacency list now. So here adjacency list of 0. Okay, so this is going to be adjacency list of 0. So 0 for 0 adjacency list is going to be this b and c. B and c nothing but 1 and 2. Okay, because I can reach b and c directly from this a, right? Same row or same column, right? And same way for this stone 1, okay, that simply means b. Okay, from 1 b, from b I can move to this e and a, right? So simply means e is nothing but 4 and a is nothing but 0. Okay, so this is what I'm creating. and from C, if I see from C I can move to this A, right, and D. Okay, so A is 0 and D is 3. So here for 2 I need to write 0 3, right, because stone 2 connects to stone 0 and 3. Okay, this is what I am actually doing in the adjacency list. And for this 3, same way for this 3 you will see that D is 3 now, so D I can go to F or C, so 2 and 5. Okay, and same way for 4 you will see that we can go to 1 and 5. Okay, 4 is nothing but E, for E, F and B is 1 and F is 5. Okay, then for 5 you can see that 5 is nothing but F, from F, D or E. D is nothing but my 3 and E is nothing but 4. Okay, so this is what I'm creating. Okay, adjacency list, right? So this is done here, and yeah, it's done. Now after that what we need to do, so we have to just let's create one variable, a num of connected components, and initially let's give the value 0. Okay, and here also create one boolean visited array, new boolean. Okay, give the same size n. Okay, and then after that we have to traverse all the stones using DFS to count connected components. Okay, so what is actually going to happen here, see here, from 0 I'm going to mark this 0 as visited. Okay, first, then I go to this one, I'm going to mark this 1 as visited, and I'm going to check the neighbors. So 0 is already visited, I'm not going to visit it. Then I'm going to go to 4 this. Okay, so I'm going to mark this 4 as visited. Okay, so now 1 is already visited, right, 1 is already visited, so I'm not going to check. Then for I'm going to this 5. Okay, marking 5 is visited. 3 is already visited, no, 3, so 3 is not visited, so I'm going to this 3. Okay, marking it visited, 3 mark it visited here, and then check the neighbors for this. So 2 is visited, no, so I'm going to mark this as visited, so 2 is going to be visited. 0 is already visited, 3 is already visited, I'm not going to mark this. Okay, then 4 is already visited, so I have visited all the things, right, using DFS. This is how my DFS is going to work. Okay, so using just 1 0, okay, I can visit all other stones, right? So this is what's going to happen here. Okay, so here inside this what I'm going to do, for int I is equal to 0, I is less than n, I plus plus, and here I'm just going to write if it is not visited. Okay, if it is not visited, then in that case, okay, visited of I. Okay, if it is not visited, then here I'm just going to call my DFS. Okay, and in DFS I'm just going to pass my adjacency list, and I'm going to pass my visited array. Okay, and I'm going to pass my I value. Okay, and here after that I'm just going to increment the count of num of connected components. Copy this, go here, paste it here, and increment it. That's it. Okay, then once this is done, then we have to just return the maximum stones that can be removed is total stones minus number of connected components. Okay, so here I'm just going to return n minus number of connected components. That's it. Okay, so this is done. Now here let's define this DFS. So simple now, private void DFS, and inside this just pass my adjacency this list of integer array. So here let me just copy it directly now. This one we need, pass it here and pass my visited. Okay, copy this, paste it here, and what are the other things we are passing I. So here let's write I. Okay, inside this, first thing that I need to do here, I have to mark my current stone as visited. Okay, whatever the stone that I'm going to check, so visited of current stone. Okay, so stone, why I'm writing stone here, right? Let's write I now. So okay, so here, okay, you can do one thing here, write stone for simplicity. So visited of stone. Okay, this stone I have to mark it as visited. So here I'm just going to write true. This is done. Then after that we have to check the neighbors of this one now. So for that I'm going to write for int neighbor adj list, and we are going to visit all the stones right in the this adjacency list. This is done. Then after that inside this again check if we haven't visited this neighbor. Okay, so if not visited that particular neighbor, okay, and here if it's not visited then just call the DFS again. Just copy this, paste it here, and now in the DFS instead of I just pass your neighbor. Okay, that's it. Now let's try to run the code and see if there are any code issues. We will try to fix them. Okay, so wonderful. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.